Hello guys, and welcome back to another video. So today we are trying to get this controller and explaining how I coded this to work as a mouse and a keyboard. So how this entire thing started initially was just a joke about trying to reprogram the controller to work with anything. And in the end, me and the boys were on a clan war, and it was clan league war. And I just for a joke said, I might as well download BlueStacks and then, try to get some wins through the controller. So one night after, I think was it through the exams? I don't even remember. It was somewhere around the exam period. I sat down while on a Discord call with the boys, and I was coding this thing, and it actually worked pretty well. So that's what I'm trying to explain to you guys now. So I did not change any hardware on this controller. It is as it is. There has been no change whatsoever, because this is only taking inputs. There is no actual data being output from the controller to any output pins on it. So yeah, we'll get into what I have done. And also, nice touch above right there. I've got myself a small old Microsoft cam. It's just a webcam used for old laptops, let's just say. But it does its job. It can get stuck onto a bookshelf, which I have done right now. And yeah, it just does the job. So right now, I'll explain you the code first. We are using three libraries: the keyboard layout, and the mouse library. So what each of these does is it imports from a separate file whatever the information is needed to run this code. So keyboard.h and mouse.h are to do with serial communication, because you are using this as a human input device, an HID device, and you're sending information to your computer. So you need these three. So these are the two analog pins which are connected to this, and these are the mouse button pins. That means these two and these two. So these are all the keyboard pins which are going to be connected to these buttons underneath. So first we set up just the initial values of each axis, the current, and then we also set up variables to store the current values of the axis. And this is the sensitivity. Now I'll get to this part somewhere later. So these are a few flags that are used to store whether the mouse button is pressed or not, which I will also explain a bit later. We'll get to this part first. So the setup: pin mode horizontal pin input means you're calling what pin number it is. So horizontal pin is A0 and input. So that means you're setting those pins as an input. The same thing goes for every pin on this board. All these pins are configured as inputs. So then we map these analog inputs to 0 values. So what that does is, as soon as you plug this device in, it takes a value from the current position and stores it as a 0 value. Now why do we do that? The mouse move function, which I will get to you later, can take both negative and positive values, and we want to start with a fresh slate where the current position of the joystick is 0. So the default position is labeled as 0. So that's what this does, vertical 0. And then you start the mouse emulation, and then these are setting all these buttons, the keyboard buttons, as inputs. Then you start the serial data communication here. Now this is where I was getting at. So you have a certain value that you're reading from the analog input, and you subtract that with your vertical 0 value. So for example, imagine when the handle is centered, your value is something like 512. So you don't want to store the 512 in this value, vertical value. You want to store 500. You shouldn't be storing 512 there, but instead that 512 should be a center value, and you should be able to get this value in both negative and positive numbers. So what we do is we set a certain zero value, that means the value of the potentiometer when the handle is centered, and we take the current analog reading and you subtract it from the zero value. So it's basically like an offset. So if my reading at the far right end of the handle is 1024, and my zero and the position at 0 is 512, the subtraction is going to be 512 right here. So imagine all the way at the left side, my value is going to be 0 on the potentiometer. You take 0 minus 512, so that this value is going to be minus. So that's a neat part. Left is minus, right is plus. And this function, the mouse move function, is able to detect that. And the same thing goes for here. So as long as the vertical value is not 0, this function is carried out. So that means 0 means this value. As long as the handle is not centered, you're going to take some action using this mouse move function. So what's this? There's 0 here, comma, and then a separate function here, and then another 0. So you can see it right down the screen. It says the parameters that are being called through the function. You have for the X positioning of the mouse, Y positioning of the mouse, and the mouse wheel positioning. So right now we are just using the X and the Y positions. So for vertical values, for the vertical movement, we are not using any X movements. So we are just talking about this part. We are just talking about the Y movement. So invert mouse. So that means we are checking if the mouse is actually, we can also invert the controls. That's what's being done here. And then we take the vertical value and we divide it by a certain sensitivity, and this sensitivity, it is what was being called right here, this 256. And the lower the sensitivity, the higher the speed of the mouse. Right here, higher the sensitivity, slower the mouse. And they should be around 500, because the maximum and the minimum values this thing would ever go to is minus 512 and plus 512. So if it was greater than that, the mouse would move at all, because the divider would never, the final answer after the division would never reach 1. So right now I have it set at 256. I mean, I could recode it as 64 and re-upload. And then moving on, that's basically this part. So the same thing goes for this. Now there's a -1 here, if you noticed. That's because I sort of messed up the wiring on one of these potentiometers and I sort of inverted it. So there's a -1 here, but it works all the same. You take the X value here, this entire thing is the X value, the Y value is here, and the mouse wheel value is here. So that's for the mouse move function. So as you can see, if moving, you can see the cursor on the screen. There you go, it moves. So the more I move the mouse to the left and the right, the faster it moves. So the sensitivity actually works. And next we move on to these, the mouse buttons. So what happens is, this SEL pin 1 is your left mouse button, and what we do is, as long as your SEL pin 1 is equal to 0 and your mouse click flag is 0, so that means if the joystick button is pressed, if the joystick button is not pressed, you're able to press down the mouse button. So that means you increment this mouse click flag to 1, and then you press the mouse button. Otherwise, if this and this are equal, that means imagine that this button is pressed. If the button is pressed here and the mouse click flag is also 1, what happens is you set the mouse click flag to 0 and you release the mouse if the joystick button is not pressed. So that's what happens here. So this is to check if there is a certain button pressed or not on the joystick, if the left mouse button is already pressed or not. So this condition is satisfied when the button is not pressed. Then you increment the flag to 1 and you press the left mouse button. Now if the button is already being pressed, then this condition is true. Then you decrement the flag to 0 and then you release the left mouse button. That's what's happening here. And the same thing goes on to the right click of the mouse, the middle mouse button click, and also to click all the buttons on the mouse at once. So all those functions are called by this mouse release, mouse press, and all of these are included as definitions on the mouse library. Moving on, the exact same thing is happening with the keyboard buttons. So if digital key pin, and if this condition is true, you increment the key click flag by 1 and you output a certain key through serial communication. Otherwise, if the button is not pressed, you decrement the flag by 1 and you release the keyboard key. So that's what's happening here, and you copy the code over to all the buttons you want. So there are 2 ways to do this. Number 1 is doing press and release, which is like a normal keyboard, or you can also do keyboard.click. So what that does is, each time the code runs, you can have just one keyboard. You can have just one if condition. You don't need like an if else condition or something. What it does is, if this button is pressed, you carry out the function called keyboard.click and then W. So what that does is, as soon as you press the button, you output one letter. But the problem is, it doesn't behave like a normal keyboard at that point, because you're clicking the keyboard each and every time the code cycles. So instead of doing that, I'm using flags to simulate as if you're continuously pressing down on the key, as long as you're continuously pressing down on the controller buttons. So that's what's happening here. So there are 2 advantages of that with the mouse and the keys, because it's almost the same code being copied over. Number 1, using this code, you can prevent getting like a gazillion keyboard presses because you pressed it once. And number 2, this method of representation on serial data can be recognized by more programs that are strictly for keyboard and mouse purposes. So right at the end, it's all the same code for different keys, and at the end I included this a serial print function. So what that does is, if I open up a serial monitor, what that does is, it helps me debug. Why isn't it opening? There we go. It helps me debug if something is going on with the controller. So right now, that's what's happening right now. So if I move my joystick to the right side, you can see the values at the bottom changing. It's somewhere between plus and minus 500 right now, which is as expected. So there we go. So I could also show you something. Here's my Clash of Clans account. So this is where it all started, and it would be a shame if I don't return to this for the controller. There we go. So it all works as expected. Oh my god, it's really sensitive, this mouse. I'm still not used to how this thing behaves. So it's a bit of it's a bit of a challenge, I'll say that at least. But it works. I can assure you that. So it is what it is. There we go. I hope you enjoyed this video, and I hope you found it informative. And if you have any questions, let me know in the comment section. And thank you so much for your support. See you.